Morning, good evening, good afternoon, good afternoon. Welcome to EIG's first in a series of webinars on optimal ops, creating resilience in a digitally disrupted world. We're trying to set the stage for industry transformation, for resilience, optimization, and leadership in disruption. And we have a lot of disruption out there, don't we? So I want to welcome our guest panelist here, Aaron Parr, founder and CEO of enroute.io, from the great state of Florida, where it's a little bit warmer.
Good morning.
Dr. Irene Legiec, founder and CEO of IALS Consulting in the great state of Delaware.
Good morning.
And Jim Vries, I'm founder of Enhance International Group here in Pennsylvania, in Bethlehem. We appreciate you taking the time today to join us in today's webinar and building your evolving resilient enterprise and getting into a little bit of a new topic for us, optimal ops. Uh, Most importantly, we hope that your family and friends are healthy and safe and wish you all the best for the holidays, upcoming holidays. This webinar series is focused on setting the stage for industry transformation, resilience, optimization, and leadership in disruption. This is the first webinar focused on creating a resilience in a digitally disrupted world. The second webinar is about how to onboard teams to optimal ops methodology. The third webinar, upcoming in February, will be on incident response and continuous improvement using these basic concepts. Our deliverables today is to understand the concept of optimal ops, recognize the limits of traditional optimization, apply systems thinking and first engineering principles, let's say, or physics principles, if you like, explore digital integration pathways, and evaluate practical case studies throughout. So with this, I'll turn it over to Irene with a bit of a background of ILS. Irene.
Good morning, everyone. So, Improvement in Lean Services Consulting is an organization where we focus on 6 main bucket areas for our clients for continuous improvement and operational excellence. We'll do a lot of engineering optimization from a capabilities planning perspective. The other thing too is a lot of ad hoc program management. If you think of us as strategic resources that are variable. So if you need a rent a director or rent a VP of engineering, I can come in, assist, develop some programs and systems, and then provide that mentoring ongoing. I have over 30 years of experience. I actually started out as a research scientist in DuPont, spent 27 years there, and grew into management roles, and then went into operations, leading engineering design teams as the VP of engineering design for Covanta, which is now Reworld, and then the biogas plants for Air Liquide in the United States. So a lot of R&D, engineering, and operations experience to serve the clients. Thank
Thanks,
you.
Irene.
Hey, good morning, everybody. Great to be here with my two esteemed colleagues. My name is Aaron Parr. I'm a chemical engineer and Lean Six Sigma black belt. But more pertinent to today, I've been the person at 2 a.m. trying to explain to my boss why a solved problem just cost us another $1 million. I've watched teams work incredibly hard using the right tools, but still missing the leading indicators that ended up mattering the most. And so I'm excited to get into that more today. But that also is partly the reason why I founded my company 2 years ago, enroute.io. Our mission is to accelerate startups' growth plans by helping them see and uncover and explain to their investors the 2 to 3 most critical decisions that could potentially put them out of business. We do that through human-in-the-loop AI systems that work to amplify their team's expertise rather than replace it. And I'm excited to be here to talk about how that relates to optimal ops.
Thanks, Aaron and Irene. Appreciate it. With that, just a brief background of Enhance International Group. We're a group of 80 partners spanning the globe, covering people, process, data, and technology. Today, of course, we're focusing our strategy is on optimal ops and how that can become a program within your company to bring you to that next level of performance. Very often, many companies have Lean Six Sigma programs, and at some point in time, they kind of peter out. So the question is, how do you get over that maturity level of 3, over that wall? And that's what we're here to talk about. And as it says there, end-to-end optimization, one pedal at a time. How do we start using optimization, AI, and any other buzzword that you come up with to power your company through people, process, data, technology? That's what optimal ops is about, and we'll get into here. So I just want to start us off with just to say, what is the overall problem, or what's the challenge that we have? This is a MIT Oak Ridge study using the iceberg index. You might want to look that up. They did find that AI systems are technically capable of performing tasks equal to about 12% of the US labor market's work, particularly in routine cognitive roles like finance, healthcare, and professional services. So AI is coming. And what does that mean to us? Well, AI and automation from a global across industries is very applicable for highly mature organizations. The organizations that have not reached that maturity level are kind of stuck. And if you look at how mature our operations are globally of the US versus Asia versus China and Europe, you might be a little bit surprised that we're lagging. The US is lagging the rest of the world. The US has about 29% are using AI somewhere in the facility and 38% piloting AI solutions. But when you go to other countries like India and China, you'll see these percentages much higher than us. So we have a bit of a dilemma. But we know that from a profitability and efficiency perspective, the most mature companies are the ones that are able to boost profits and be more efficient compared to their counterparts. But only 7% of all organizations have reached like a maturity level of 5 or 4, maybe 15%. But there's still a small fraction of our entire industrial base is at these higher maturity levels. So how do we boost ourselves to that next level is what we're here to talk about. And we're proposing that optimal ops is one of the mechanisms, not the only mechanism, but certainly a mechanism to help out in that way. So as we face the next few years of AI becoming more and more pertinent to everyone, and we have more lights out factories being built around the world, having mature processes underneath is going to be key to be able to create a lights out factory. So with that, just wanted to set the stage there. You know, the world is moving at a rapid pace, and the question is, are you keeping up? Are you able to operate in a world in 5 years where AI will be much more prominent than it is even today? So that sets the stage for us. The problem statement that we're trying to solve from a very high level, macro level, and then we'll get into the introduction of optimal ops, and then the problem statement on why modeling an average is suboptimal. So we'll get into what that means. The optimal ops core concepts, some of the core tools and methodologies. Intermittently, we'll be throwing in some case studies and examples, and then we'll transition to AI digital, the future of optimal ops. So with that, we just want to throw out some concepts that these have been around for years. None of these are new concepts. Systems thinking, how you interconnect analysis operations as a whole ecosystem. So you're looking at your whole facility, whether it's a manufacturing facility or a chemical plant or a hospital. How are you interconnected? It's an ecosystem versus just a streamlined process. Sometimes we think of just cells, but systems thinking is saying, how are we all interconnected? Early warning detection for operational drift. That's another concept that we often see, is that having the detection of things. In the past, it was people on clipboards walking around with a pencil. But today, with IoT, lots of different things today that we can to detect things in real time, new video imaging apps and so forth are driving things to that next level. Integration of first principles with machine learning. What we're talking about here is there's a lot of first principles that sometimes get lost. We'll analyze something to death, but forget about the first principles. You can go from one direction is first principles makes a bunch of assumptions in an ecosystem, but at the same time, if you just optimize without understanding first principles, you'll end up sub-optimizing. So finding that balance is what we promote in optimal ops. And again, taking traditional engineering plus digital intelligence and working together to drive overall. And again, these principles have been applied over the last 20, 25 years in everything from manufacturing, supply chain, even transactional processes. So with that, I'll turn it over to Aaron.
So all of these tools, as Jim said, have been around for 20, 25 years. So why are we talking about this today? Why does this matter now? So there's a couple trends. The first, and I think an overall good umbrella to look at this, is really stuff that starts falling under Industry 5.0. Sure, we've heard the term, maybe we've even rolled our eyes at it before. But here's a stat that I think helps level the playing field. 67% of executives report that their traditional optimization methods are failing in volatile environments. What does that mean? That's not underperforming, that's failing. That means that their traditional optimization models aren't even working a little bit. And to try and put a dollar figure to that, about 4.5 million. That's the average annual loss from things like undetected operational drift in manufacturing. So that's not, a one-off critical failure. That's drift. That's slow, invisible degradation. And today, as a part of Optimal Ops, we're going to talk about how to uncover that drift. Now, when I first saw this stat, I was working with an incredibly talented operations team, and I was kind of like, that's not really us. We're pretty robust here. We have a solid understanding around our processes, and we have good standards set up around them. But then I dug a little deeper, and I asked myself, when was the last time we had actually detected a problem before it had showed up in our financial variance report, something that we reviewed weekly, but more in depth monthly. And a lot of times in today's environment, for the three reasons I'm about to get into, sometimes a month is too late. Sometimes a week is too late. And just as a quick example, we'll get into this more later, but we had a heat exchanger that was performing within spec for 9 months. And we had inspections, we had standards, all our checks were green, preventative maintenance. But after review one quarter, when we were looking back, we realized that it was actually causing a 7% drop in throughput, which was within our spec limits, not catastrophic, but over the course of a year, that would be worth about $1 million. So these types of problems aren't new, but they're increasing in complexity. And that's what I want to get into today. So 3 areas: supply chain volatility, fatigue from previous failed technology rollouts, and then, of course, a big new wave of AI pilots have been coming to fruition over the last 2 years. So what are all of these changing today versus 5 years ago? So just real high level, and of course, this isn't an all-inclusive list. These are just the big 3 that we wanted to touch on. Supply chain volatility, right? First, there was COVID. This year, there have been tariffs. So it looks like volatility is here to stay, right? It could be material spec changing. Your supplier could have quality drift that you don't control. But basically, the takeaway from this piece is that when your inputs become unpredictable, your optimization model might start to break. Digital transformation fatigue. So how many times have we tried to roll out a new piece of technology and then looking back a year later, it's just generating reports that nobody reads anymore? And then finally, AI. One of the ones that I really want to point out here with AI pilots is a lot of them are just vendors slapping AI powered on their brochure, and they're really not rooting the use of AI in first principles. So a good rule of thumb, a lot of times AI is used for automation, But an algorithm that is used to automate a bad process will still result in the same bad outcome. You'll just have the ability to do that bad process faster. So these three forces, volatility, digital fatigue, and AI hype, I think are helping set the stage to explain why traditional optimization is breaking, and why we need to move forward with some of these more legacy methodologies into something like optimal ops.
Thanks, Aaron. And we have our first and only polling question here. And what recurring problems or challenges cause you to re-optimize your operations? So there's one in there seated with skew changes. That's a very common thing that happens, skew changes, and then all of a sudden you have to re-optimize your operations. Aaron and Irene, any other ideas from you? And while our callers here uh, type in their ideas.
Sorry about that. I just typed in raw material issues with the changing dynamic and volatile market. Some of my clients have had issues with a critical raw material all of a sudden getting delayed. And so making sure that you have, you're not sole sourced, that you have other alternatives qualified, is starting to become more and more important. Aaron?
Yeah, I was thinking, actually, it really didn't hit me until this morning. I was reading an article and it talked about markets moving faster. And I think market disruptions is something that can catch a lot of us by surprise. Markets are changing faster today than they ever have before. And that's usually a problem because a lot of our organizations, we're designed to be looking inward. We're designed to be looking at ourselves and what we're doing, and not so much as what our competitors are doing. And it used to be that an annual market study could help you grasp where some of those trends were heading, but sometimes trends can change every month or two, right? And if you're just basing your business strategy on how you're going against your competitors against an annual data point, then you're missing the mark.
Thanks, Aaron. I think these two that were typed in, new manufacturing technologies. Yes, if you're adding another line, adding technology on a line, adding instrumentation, that can be very disruptive. In order to get increased throughput, you update your manufacturing, and then you have other challenges. I like the other one too on the warehousing. Uh, the when you are expanding from your warehouse, that was a good one. It kind of disappeared for some reason, not sure why, but that was a good one. Any other ideas? We'll come back to this at the end and keep on typing in where you think these are and keep your questions in the chat. I see, oh, there, Dan put it in the chat. Perfect. Thank you very much. With that, Aaron.
All right. So we're going to move kind of from the problem statement. We looked at it from a broad standpoint. We talked about things like supply chain volatility, digital transformations failing, AI pilots failing. So how does this relate to traditional optimization? And Jim and I both said that, a lot of the traditional optimization models are broken. So what do we mean by that? Basically, in one sentence, it's static optimization can't keep up with today's dynamic ecosystems. That's the stuff I described in the previous slide. But this is kind of the way I like to look at it. Picture you're driving a car, right? You're heading to work. Traditional optimization works like setting your cruise control to 65 miles an hour because you got on the interstate, and that's the speed limit. And this works fine until the road conditions start to change. And if the road starts curving, suddenly there's rain, there's fog, there's construction. I used to work in South Jersey, and there was a project on 295 that started in 2013, and it is scheduled to finish in 2032. So right? That was a common roadblock for me. It was a recurring issue. But my cruise control still locked to 65 because that was optimal when we started. And that's really what we want to get into. Your plant, your business processes, that's your car. And how can you respond to things like variation, changing optimums, like a rainy day versus a sunny day. So really the idea that I want to go over quickly is modeling to the average leads to missed warnings. And Jim is going to dive into that in a lot more detail, I believe on the next in the next few slides. But this is where a lot of dollars are disappearing, and it's because it's slow and it's not obvious and it's not acute. So when you model to an average, you're telling your system, as long as we're hitting the center of the spec, we're fine. But here's what we're going to get into here on the next slide. The distance from the center of the edge is where all of the value is. That's where the your competitive edge is. So I want to go over another stat. 68% of optimization initiatives have failed to deliver expected ROI. It's because they're optimizing to yesterday's optimum instead of and using yesterday's assumptions, or more realistically, an average of the last month for this month. And all of the things we talked about, like fatigue, operational drift, unpredicted failure modes, all of that goes uncaught with that type of modeling. And this is also something that multiplies. It's a compounding effect. So think of it like this: you got a small crack in your cement driveway, not a big deal. It's within tolerance. That crack allows water in, but then the water is going to cause expansion, and now you've got 3 cracks. And then by the time you pull back in your driveway and you look at all the cracks, it's too late, right? You have to replace your whole driveway instead of that one simple crack. So we live, to sum this up, we live in a dynamic ecosystem, and static models are teaching us that it's okay to lock in permanent sub-optimization. So now that we understand what's broken, here's how we can fix it. Irene, could you take us to the solution, please?
So we're going to talk about the optimal ops core concepts here and how you can really drive to these solutions. So if you can go to the next slide, please. Let's think about a problem, out at the plant or in your operations, whether you're a chemical manufacturing plant or you're a parts manufacturing, whatever your processes are. 10% of your information is visible with the metrics and the KPIs. And as you're taking a look at a problem or a risk area, that's going to be visible. You're going to see it in those areas, but there's a lot of undetected failure modes that unless you do a deep dive, you need to, you're not going to be able to see them. That 90% is hidden. What can happen here? Operational drift. You'll see gradual, sometimes, small movements towards system boundaries. And if it's still within your permit limits or within your operational limits, people are going to ignore it. Cumulative wear on critical components. It's going to be fine until it absolutely fails. Root cause blindness. You're looking at the symptoms and you are ignoring the root causes, and it just compounds more and more. 78% of those operational failures showed signs 4 to 6 weeks before the event occurred. So the thing is you want to look proactively for those signs. You want to be doing your PMs. You want to be looking ahead to avoid those catastrophic failures before they occur. Jim?
Thanks, Irene. So as we talked about before, the dynamic ecosystems is not the average system. So very often we work on the assumptions of normal distributions and averages, and that creates a performance gap in manufacturing, supply chain operations, in transactional processes. They're constantly changing. So taking the average of an average and then making the decision, you end up with subpar decisions, and you miss critical shifts in the operations. In the practical perspective, 100 years ago or 50 years ago, even 20 years ago, we were not able to manage that in real time. But today, with today's technology and optimal ops principles, it can easily be modeled today. And so Aaron and Irene talked a lot about operations drift. It's constantly due to multiple factors that are going on within your operations. And of course, the optimization requires a dynamic responsive system. And in the variation visualizes your opportunities to optimize. So again, we're looking at how do we move from a static world into a dynamic world. And in the past, again, it wasn't just really practical to do that. And so we're moving from point to constantly changing. We're moving from isolated processes to interconnected systems. We all know that it's in the handoffs where the pain is in processes, whether it's a transactional process or a operations process. It's those handoffs that kill you. Um, you're looking at fixed assumptions with parameters and versus adaptive response to the given conditions that we're in today. Then going from periodic reviews that are maybe quarterly or monthly into real-time adjustments, but not to a point where you're in submission. Again, today's technology, we can manage this. And static optimization really doesn't look at variance in your operations, your day-to-day, minute to minute, second to second. It doesn't look at it. And in it's the variation. If you're a Lean Six Sigma Master Black Belt, you would know that it is in variance that you find your problems. It's why people aren't performing what they said they were going to perform. That variance is what's costing you. And it's very hard to quantify in the past without technology. So again, what we want to get down to is to detect, respond, and optimize. Detect what? To recognize the natural variation of the process and being able to route out the noise, and then respond effectively to the actual signal, and then convert these drifts. So these drift types of things that are happening, how do we make sure we react as soon as that drift starts happening instead of waiting 6 weeks, eight weeks, or 3 years to respond? So that adaptation is very important. So what this looks like is overall, when we look at the overall output of optimal ops, the output is here on the y-axis. On the x is different things that are performed, different stages that you perform to become more mature. So we rationalize through segmentation, we visualize, and then we stabilize. So stable ops in the past that was used back in the 90s and so forth in 2000s that GE launched would stop here. But to optimize, to get to entitlement and beyond entitlement is where optimal ops comes into play. Because just to stabilize a process, you will get a natural shift for free. So you'd often hear reduce the variation and get your shift for free. That was a big saying back in the 90s. But now the question is, how do you get to that revolutionizing stage, that shift? And very often you look at industry best practices, but now with technology, we can get to that next shift with optimization, with simulation. We're able to get and revolutionize our processes. So here we were seeing between 2 and 5x throughput just by reducing variation. Instead of optimizing on the average, optimize by reducing the average or the variation in the process and getting that step change. And then we were much higher from entitlement, so we could have this discussion. If you try to have this discussion when you're back at rationalizing and you're operating this way and you try to shift your process, all you're doing is shifting your noise and you don't get the gain that you thought you were going to get. And that's the mistake that many, many companies make year in, year out. They don't clean the process. So look at it as a cleansing stage in the process. So what does this look like overall? So one of the biggest mistakes folks make is looking at their data. they look at their data on a monthly or weekly basis. Well, that immediately means that you're looking at the average performance over those time frames. And so the variation that you'll see on a monthly basis may look like that's about as much variation as you'll be able to see as the red. In the yellow, if you look at it from a weekly basis, you'll see that the variation in your performance is heightened. And even if you get down to daily or hourly, it will become even more heightened. Well, what does that mean? Well, that means you can see more. You can see the noise or the variation or your failures and not hitting your entitlement of your process. So if you say entitlements 60, 70%, I would like to get to that next level, that benchmark, I want to get there, then if you're on a monthly basis, you're limited by the bar that you can set because you can only set the bar for what you can see. And obviously, when you move into the yellow, the bar gets higher and higher and higher. So the bottom line is you're leaving a lot of money on the table by looking at things at the average of an average of an average. And you're becoming moving from a very reactive world, looking at things at a monthly basis, to a proactive world, looking at it on an hourly basis. So we want to become more proactive. And the easiest way to become proactive is to look at the data at a finer increment of time. So that's the basic concept of stable ops as far as looking at the opportunity that's in your organization. Some of the main concepts in optimal ops are Lean Six Sigma. Of course, you have to do Lean Six Sigma. Again, get the ground fruit done. But when you're done with the ground fruit, let's move up, look at system thinking, looking at strategic planning, bring in variation, bring in your constraints, understand where you're robbing Peter to pay Paul. And of course, underlying everything, you need to build some kind of strategic, tactical, and operational KPI hierarchy to link everything together. So this on the right here is the simplicity loop of no returns approach. Keep it simple. Simplicity leads to solving the problems over and over again until the company gives up. So what we're trying to get at here is, in simple terms, what I see over and over again is a company's not performing well. They come in, they do lean, they do Kaizen events, they clean it up, they get it up to a certain level of performance, as to say maturity level 2 or 3. They put in standards, they're doing very well, and then they don't know what to do next. They get stuck. And then what they do is they fire all, in the beginning, they hired all these people to clean up the mess. They had a bunch of savings. And then they get to the point where they say they're going to fire all those people that cleaned up the mess. And then after a period of time, it slowly erodes and they start all over again. So I call it the 1, 2, 3 step, because everybody's trying to get that level 4 performance from a maturity perspective. They can't reach it because they don't have a way to navigate that wall. And so what we're saying here is this is a way to get from a mindset perspective for your organization to overcome those barriers. With that, I'll turn it over to Aaron.
Thanks, Jim. So now I want to help differentiate and at a very high level go into some of these core concepts. Basically here to explain what we think of when we say optimal ops is systems thinking plus theory of constraints plus Lean Six Sigma, all integrated with technology to help sustain it. And that's kind of your 1 + 1 = 3, right? They all of the sum of the parts is greater than is greater than each individually. So real quick, going through these three. Systems thinking, this is everything is connected and how is it connected. So you got a company with 2 lines. One is painting the parts and then one is assembling them. So the painting team will say, we want to run big batches. That way we don't waste any time switching between colors. So they do all the reds and then all the blues. And then their assembly team says, we want small mixed batches. That way we don't have to build up inventory. So both of these teams are doing the right things for their own individual teams. everybody's hitting their own individual KPIs, but overall the company loses. Why? Because the painting team is making really big batches that the assembly team doesn't need yet. And so their parts are starting to pile up in between those two processes. And that's causing inventory cost. So both teams were basically, long story short, is both teams were looking at optimizing their own area and they weren't talking to each other. So that's system thinking in a nutshell, grossly oversimplified, but stop looking at the pieces and start looking at how the pieces connect. Second is theory of constraints. This is essentially finding the slowest step. So what's your slow step? I'm a chemical engineer. So in my experience, that's how you dictate the kinetics of a reaction. You look for the rate limiting step because that slow step controls everything. Going back to my highway metaphor of earlier, you got a highway, it has 6 lanes, and then it drops down to 2 lanes for half a mile, and then it goes back to 6 lanes. How fast is that traffic really moving, assuming that the number of cars on the highway is equal, right? You're only going to move as fast as those 2 lanes allow you. So Irene will get more into this on the next slide and talk about some of the nuances behind the theory of constraints. But essentially, looking for that slowest step, looking for your bottleneck, that's the whole idea behind theory of constraints. And then finally, Lean Six Sigma, right? Nothing new here. Where are you wasting time or materials, and why does the same process give us different results? So very high level example, you're filling syringes at a medical devices plant. You're rejecting 2% of syringes. They're overfilled, underfilled, contaminated. It doesn't matter. You got to throw them away, right? And you look at the industry average, it's 2 to 3%. So you're beating the industry almost, right? You're at the very bottom at 2%. But then you start looking into the data and you find something interesting. Operator A is actually rejecting only 0.8% of syringes, and operator B is rejecting 5%. So even though your average was fine, your variation was big. And you can go take that a step further and dig into the why behind it and find out the root cause. Maybe operator B was using a workaround because there was a material handling step that was awkward. And so he started shortcutting the procedure, which worked most of the time. It made his job a lot easier, but 5% of the time he created a defect product. So in a nutshell, those are some of the ideas that we borrow from Lean Six Sigma into optimal ops. And then bringing it all together, systems thinking helps you see how things connect. And then the theory of constraints helps you find what's slowing you down and where to look next. And then Lean Six Sigma will help you eliminate the waste and inconsistencies behind that. And so that's kind of where optimal ops is different. Instead of just doing these 3 things separately, it really is a 1 + 1 + 1 = infinity type of thing. And then additionally, we'll get into this. This is really the focus of our next webinar. But when we start adding things that make it easier for your teams, real-time data, predictive technology, and you incorporate it into those frameworks, that's when you can really start doing this analysis instead of once a week or once a month, once a quarter. You can look at these problems in real time. So with that, let's talk about what happens when you don't watch for constraints moving. Irene?
So, if you've ever been to the boardwalk, at the Jersey Shore or whatever shore, you probably played that game Whack-A-Mole. And it's a lot of fun. It's kind of cleansing just to, smack the crap out of something with a little mallet. However, doing this in real life is highly irritating. And if you are in operations, you'll feel like every single day is a Whack-A-Mole day where you smack down one problem and another one pops up. This is true as well for constraint creep. What does that mean? You solve one bottleneck, in one area, and then it will pop up in another area. And so it's about how do you keep tracking where new bottlenecks occur. It's constant vigilance, constant monitoring, and rapid response. If you do detect a bottleneck, if you do detect a bottleneck and you have early detection systems, you can drop that response time by 67%. And the reason why you want to do this is because on average, 15 to 25% of your capacity is lost to unmonitored constraint shifts. So it's a constant moving target, but you have to be tracking it. You lose opportunity costs. if you're not tracking it. And it is worth the investment for continuous monitoring. We're going to get further into the data analysis with Jim and Aaron, but I did want to point out that Mark had two questions
Yeah,
here.
perfect. That's what, if you want to try to answer it
Uh, well, I'll talk about the first one, the role of statistical process control on seeing process problems before it goes out of spec. It does have a role. You want to make sure that the rules that you're applying in your statistical calculations are the ones you want to have, and that it matches up what you're doing offline. And it does have a role in, especially if you're starting to trend and creep towards that upper or lower boundary condition. One of the difficulties that you have to do is how do you then translate that to the non-statistical person who's running the board or who's out in the field? And so there's a people element here of management of change. So it does have a role, but don't forget the people side, which is explaining to people what you're doing and making sure that they're on board and trained in the process.
and just to build on what Irene said, SBC is generally, those control limits or spec limits, I would call them spec limits, are generally built to protect the unit, not to optimize the operation of the facility. So if it's a operations, or even it's the max you can do to be out of spec, but it won't capture drift, and it won't capture how well your throughput, how much that affects your throughput. So what what we do is we look at and we create new operational spec limits. We'll get into that more in the next webinar, but uh, spec limits and operational spec limits is what we uh, put out, and those operational spec limits and the reasons why there's drift, as was mentioned before. All those are there to catch it before you get to the spec limit. So it's uh, related but independent. As far as how do you optimize the upper edge of your normal variation, I'm honestly not quite sure what you're asking, Mark. So maybe a follow-up question, and then I'll come back to it and see if I can answer it, because I'd be guessing at this point in time what you mean by that. So I'll go into the first case study here of a turbine generator trip that happened a number of years ago with a client, uh, and they did not address the root cause. They thought that the root cause for this generator failure was due to moisture, and so because of insulation deterioration and outdated materials, and they blamed it on that, and they went and put the generator back together, and then a number of years later they had the same failure again. Well, they didn't really get to the root cause. Well, they weren't looking at the data. They were looking at the answer and trying to work backwards to a problem. The real problem was that these generators were not built for this application. So again, this goes back to first principles. These generators were meant for steady state operation. And in fact, because of the nature of burning trash in this case, and having a an output that is never exactly 80 megawatts or 30 megawatts, it doesn't really matter. There's always a fluctuation going on, where that fluctuation causes uh, the failure. So it was a cycling unit. So the unit was not built to be a cycling unit, and with a variation in it in the operations. If they had been doing optimal ops and they looked at the data, they would have seen that variation, if they'd given that to the manufacturer would have rewound that stator differently to withstand this particular problem. So everybody wants to get the unit up and running. They rewind the generator, they fix it very quickly. They're in there, they fix the stator. If it comes up here, you can see the folks, fixing the stator. It's all great. But if you fix it the same way, it's going to fail the same way because they didn't fix it they just thought it was end of life of the generator. So that was a classic example of not understanding root cause. And if they were using optimal ops and looking at the underlying data, they would have caught what the problem is. Irene, another example?
So, talk about an example again from an energy from waste facility and want to explain a little bit about it. When you get a spike in the level of BTUs that a waste produces, it reduces your throughput. There's only so much that it can handle. So you have to really manage this. And with the financials for these type of companies, throughput is where you're going to get your revenue, especially in this current trend where it was the amount of waste being brought in was critical versus the energy produced. This real world case, that sudden spike, you could see after like week 5, it just started trending up through week 8. Really significantly limited the plant throughput. So they collected some data across all the systems, saw some patterns. They also identified, in addition to that, some drift in the performance of a heat exchanger. So it was within specs, but it was still below that operational optimum. And then using that constraint-based systems thinking, we adjusted the operations and implemented early warning triggers. And so the business impact for that is $1.4 million annual savings. They were able to implement it in 3 weeks, able to reduce, energy savings of 12% and able to solve that 7% throughput issue. Next, please.
Thanks, Irene. So I just want to follow up with Mark's question while we go back to the polling question. So Mark followed up with, he was talking about the 80% entitlement on the, let me see, showed the entitlement on the upper edge of the variation. Why do you call that entitlement? And how do you achieve it all the time? Well, it's just saying that's what entitlement is saying that you can achieve it more often than not. So you're limited, it's the 80-20 rule. So if you're able to reduce that variation, it's going to be worth so much. So that 80% is what you're doing. That is your variation of your process. If you're able to reduce some of that, you're going to have that much more to drive. So I'll follow up with you, Mark, later. I'll get a clearer explanation for you. So with that, any other comments on the problems and challenges here? Okay, we'll just move on. Aaron?
Thank you, Jim. So now I want to talk about kind of what we've been hinting at the whole time. It's how does the technology come into this? A lot of what we've been talking about are business processes, methodologies, and how we work with people, as well as some of the statistical techniques, right? But how do we use that and then transition into some of this cool technology that we were talking about to enhance this, like digital twins, using first principles to improve your use of AI, that type of stuff. So I want to recap quickly just to set the stage of where we're going from a technology perspective. So at a high level, traditional optimization fails in dynamic environments. We use static models historically, average data, point in time analysis. And we've talked about how all of these models can break apart when you add additional ecosystem complexity, as well as system thinking plus theory of constraints. You use this to build resilience. You need to see the whole system. You need to identify the real constraints to your bottlenecks, and then you need to expect those bottlenecks to shift. So what we're optimizing around today will move. And then, as Irene mentioned earlier, early warning detection can help you prevent things like operational drift. So you need systems designed to detect those signals, not just react to alarm. And the starting point for that is defining what your leading indicators are versus your lagging indicators, and then setting up instrumentation so that you're actually measuring those. You'd be surprised how often those types of things are not real-time data. Now, everything we've done so far helps set the stage so you can easily scale all of the methods of optimal ops with technology. So I used to use a lot of these similar methodologies before implementing a lot of technology. I mean, we were doing most of this in Excel or Minitab, in day-to-day meetings and physical instrumentation that we would go and get handheld measurements on. But when you use things like digital twins, you essentially lower the barrier to entry to get started with optimal ops. And then you also ensure that once a program like this is rolled out, that you can actually sustain it, right? It's not going to be another program that you roll out and then you come back 2 years later and you're like, where did it go? Who's doing this? And they're like, no, nobody's doing it, but there's a report over there if you want to read it. So one example of this technology, and this is really a focus of our next webinar, but I'll go over very high level what I mean. Using digital twins that are actually validated and physics-based and use real-time data to model your process, that can amplify what's possible with optimal ops. And I want to be very clear when I say digital twin, because I know this term gets thrown pretty loosely about. It's not a dashboard. It's not a 3D visualization, although it certainly can be. But the key is that it's a computer model of your physical system that updates in real time and allows you to optimize because of that in real time and test interventions easier than the old process of collecting the data and analyzing it in Minitab. You can test those interventions virtually before actually implementing them in reality. So going back to my earlier example of a heat exchanger with drifting performance, if you had a digital twin like that, you could flag those leading indicators of operational drift in real time, and then simulate maybe a new cleaning intervention before actually shutting down the line and trying it. So basically, the idea of implementing this technology is that you can answer questions and identify the problems much faster.
Thanks, Aaron. And as we move on, just as a wrap up here, the differentiators that we see Optimal Ops providing is this unified strategy that aligns the data-driven with your other strategies throughout your organization, and expert transformation. It's driven with the seasoned Lean Six Sigma leaders or your OpEx program. It's turnaround excellence. It transforms challenges into opportunities. We do, the human condition, psychological safety, change management, whatever you would like to call it today. It certainly integrates with those principles, whether you call it lean or whatever you want to call it today. It is a rapid measure impact because you're seeing data and you're getting that feedback immediately on whether you're performing, how you're performing relative to a target, and the target is meaningful. That's really the difference here. You're not waiting to the end of the shift or the end of the week to find out, are you performing aligned to your target? And everybody understands the target and the value of that target. And then using the software that's out there today, it makes it very easy to deploy these type of technologies. Although even 10 years ago, we were deploying to some degree, but with agentic and so forth and generative AI, it becomes even easier to integrate today. So hopefully you enjoyed the webinar. And I'm sure you have some questions and comments, so please do follow up with us afterwards. And we'll be more than happy to follow up with you. Again, this is the first of 3 webinars, and some of the things that Mark asked, we'll be getting into our second webinar coming up in January. Aaron mentioned the digital twin technology, the real-time optimization and predictive analytics, and bridging those first principles and that proverbial operational versus spec limits and what is the piece of the pie that's available. That's often overlooked, and operational versus spec limits is one of the key concepts that we will be addressing in the next webinar. We just didn't have time to address it this time. So with that, turn it over to Irene.
So if you think about what are the next steps, we had a really good overview of what optimal ops is. So how do you do a next step? So if you have a constraint or an issue either at your plant or you know of a client that does, schedule a discovery session with us and so that we can understand and assess your operational constraints. We could hold a team onboarding workshop with key stakeholders and then conduct some performance baseline analysis. So think about the next steps. What are your needs, and how can we help solve them? Upcoming webinars, Jim, to talk about. And so quick Q&A session. Do you have any questions about implementing optimal ops in your organization? Use the chat feature or raise your hand and join the discussion.
Thanks, Irene. And feel free to enter that in. We'll just close it out here with any closing remarks from Aaron first.
Yeah, certainly. First, thank you everybody for tuning in. It's always a pleasure to go over stuff like optimal ops because I truly have seen this tool make a difference, a significant difference in variation and ultimately how well. I mean, at the time we were implementing it in a plant, you can implement it in all sorts of businesses. It is pretty agnostic in that perspective, but in this case, we were implementing it in a plant, and we primarily implemented it with the hourly shift folks. We had the shift supervisor involved, we had operators involved, and we had mechanics involved. And it is arguably one of the only programs that I saw rolled out at a corporate level and pushed at all levels through the organization. And every single person at that plant loved it and saw the value in it. And certainly I've seen other good methodologies and things that people at the plant, but this one was really special because the operators saw the value in it, the shift supervisors saw the value in it, the leadership saw the value in it. And so I'll leave it at that, but it truly is a way to get your employees involved and get them excited about improving the way that they work.
Irene?
So you bring up a really good point, and it's the people aspect. We're talking a lot about technology and computer systems and data, but at the end of the day, it's about the people that are running the plant. And so management of change is going to be critical here as you're implementing these type of systems, making sure that your people understand the why. Why are you doing this? Why is it important? How are we going to solve this together? Don't forget the people aspect as you go through it, and set the stage for that up front. And so that this way, when it finally does roll out, people are embracing it.
Thanks, Irene. Thanks, Aaron, for help put this together. It's really a fun webinar for me, having been doing this for over 25 years in different companies and doing it at the company where I met you, where they're happily, I've heard they're still using it today, even though we're all gone. So it's still active, even though we're not there. So that's sticky. As sticky as it gets for a program. So it's great to see that it still does work. Again, I've applied this in sales, marketing, every part of a company that you can think of. And these principles do apply everywhere and often overlooked. And variation is the root of all evil. And not understanding it and and moving from being reactive to being proactive. Most people are walking around fighting fires every day. And what we want to do is move into an environment where we can be proactive every day. And this mindset is a clear mindset to help you get on your way. Again, I want to thank Aaron and Irene for this webinar, and thank you all for joining us, and wish you a Merry Christmas, Hanukkah, and any other celebration that you have during these New Year's celebration. All the best. Take care. Be safe.